Hi, welcome to this lesson on half-life. Could you start by writing today's date and title and doing the starter in your book? Pause while you're doing that. Okay, the starter asks, if a farmer has 1,000 bags of corn, he sells half of them each day, how many bags does he have left after the third day? So after day 1, he's got 500. After day 2, he's got 250. After day 3, he'll have 125 left. Okay, so if you got that right, give it a tick. When will he be out of corn? Well, he won't ever be out of corn because there will always be half of the previous days remaining. So he might get down to like half a grain of corn, but he will always have some corn. Now, half-life relies on the fact that radioactive decay is a random process. So by random, we mean we don't know which nuclei are going to decay, and we don't know when a particular nucleus is going to decay. Half-life is defined as the time taken for the activity of a radioactive sample to half, or the time taken for the number of atoms of the radioactive isotope in the sample to half. Can you take down these definitions of half-life as you'll need them in your notes? Right, for homework, I set for some of you to do this experiment with M&Ms and counting the number of M&Ms with the M facing upwards. This is a way of modelling half-life. For those of you who haven't done it, this is me having a go at it here. Let's get rid of that one because it's broken. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and I think that's it. So that was 31. Now you don't want to sit through me counting out all the rest of these as I go through, so I will speed this process up a bit. We repeat this multiple times until we've run out of M&Ms, or in this case until I ran out of my piece of paper where I was recording the results. Each time we took out the ones that we'd previously counted, so the number was going down each time. Okay, so we're already down to just a handful of M&Ms. We've only got 3 left, and we have to put zeros in when we throw them down and there aren't any. So, how do we use a half-life graph to find half-life? Find the maximum, half it. Draw a line across and a line down. The half-life is the time you get on the axis. So, if we draw a half-life graph. So this is my graph of the experiment that we've just done. And if I want to find the half-life, what I need to do is I need to find the maximum number, divide it by 2. So if we say it's about 32, we're dividing that by 2. 32 divided by 2 is 16. So from 16, we're going to draw a line across and a line straight down. And that tells us that our half-life is going to be 2 throws. So approximately every 2 throws, the number halves. We can check that on our graph. If we half it again, that takes us to 8. And go down again. Well, that's just taken us to slightly more than 4. So the idea that it's every 2 turns it's halving seems reasonable. I can half it again. Across and down. Just over 6. So actually, our half-life there looks like it's going to be about 2.2 throws. Okay, using the knowledge you've got so far, can you please do the PEQ that I have uploaded onto Fronter? Just pause this a moment while you do that. Right, so the answer to question 1A. For the first part, you needed protons and electrons in either order. The second part, neutrons. The third part, electron, then nucleus. Has to be in that order. Part B, the half-life is 2.7 days. And then for part C, you need to put the source into the water at one point and see if the radiation is detected in the polluted area. Right, so let's have another look at a half-life graph. Again, we're going to start by finding the half-life by getting the maximum. We need to half it, so half of 100 is 50. Find 50 on our graph. Draw a horizontal line until we get to the curve. Draw a vertical line downwards from there. Use a ruler ideally, hard to do on a screen. And then the value that you get is going to be your half-life. In this case, it's 10 seconds. Be careful to read the unit off of the label. Right, some other questions we might get are of this form. So, giving you the half-life and the activity, what will be the activity in 90 days? You work out how many half-lives have passed. So 90 divided by 15 is 6 half-lives. And then we need to half the activity that many times. So 4,000 divided by 2 gives us 2,000. Divided by 2 again, 1,000, divided by 2, divided by 2, divided by 2, until we've done it 6 times when we get an answer of 62.5. Another type of question we might get, looking at a sample and being told the activity now and in the future, and then working out the half-life from that. So what we need to do is kind of like the reverse process with these questions. We're going to start by working out how many times it's halved. So in this case, we're going from 600 down to 300 to 150 and then to 75. So that's halved 3 times. So 3 half-lives have passed. We know that the total time for that was 300 years. So 300 divided by 3 gives us a half-life of 100 years. Right, now there's a worksheet on half-life calculations for you to do. Please upload your answers to Fronter. Thank you very much.